Okay, so in this video I'm going to go over the section in your textbook. I think it's on page 491 in your physical book. That's 14E, Symmetry Properties of Circular Functions. So I basically just replicated what they have on that page. So I've just written here Q1, Q2, Q3, Q4 to stand for the 4 different quadrants. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So the first thing we want to note is where the different trigonometric functions are positive and negative. Which quadrants are they positive in, which quadrants are they negative in? So the trigonometric functions being sine, cosine and tangent. So let's just take quadrant 1 for example. We know that sine, well, the sine is defined as the opposite side divided by the hypotenuse. And so if this were a unit circle, the hypotenuse is just 1 because the radius of the circle is 1. And so this side length here of this triangle would be the value of sine theta. And so we can see that that's in what we would think of as the positive y direction. So that value is going to be positive. For cosine, it's the adjacent side of this triangle. So this triangle here, divided by the hypotenuse. Again, if it was a unit circle, it would just be this length up to here. And again, that's in the positive, what we would typically think of as the positive direction, in the x-axis direction. So the cosine of theta here, this theta, is going to be positive as well. And remember that the tan function we can define as, if we say tan theta is equal to sine of theta divided by cosine of theta. And so whenever sine and cosine of theta both have the same sign, sign as in sine, so plus or minus. If this is positive and this is positive, then tangent is going to be positive. If this is negative and this is negative, then the two negatives cancel and tangent will be positive as well. But if one of these is negative and the other one is positive, then we'll have a negative sign out the front, so the tangent will be negative. So that's how we can figure out where tangent is going to be positive or negative. So for example, again in quadrant 1, we just worked out that the sine is positive, the cosine is positive, so tangent will be positive in quadrant 1 as well. So quadrant 2, we would have, so if we're considering the angle that would be right around here, so this angle here, for example, really any angle in this second quadrant. But if we just use this line that we've already got here as just our standard angle to look at in quadrant 2. So we're looking at this triangle like this. We can see, we'll look at sine. This one here, again, is in the positive y direction. So sine is going to be positive in quadrant 2. The cosine, however, is in the negative x direction. So cosine will be negative. And since we have sine positive, cosine negative, there's going to be a negative sign, which will make the tangent function in quadrant 2 negative. And so I think it goes through this on Let's see. One of these pages above tells us where those functions are, just so you have a reference in your textbook as well. Finding oh, it's the same page, just below. Yep. So yeah, page 491 and 492 also tell you what I'm telling you now, where these functions are positive and negative. So let's just move on to quadrant 3. So now we're looking at this triangle here. So we look at sine first. Now we're in the negative direction, negative y direction, because it's this line here we're considering. So that's going to be a negative sine. The cosine is in the same spot. It's this one here. So that's negative cosine. So since sine and cosine both have the same sign, they'll cancel out. So tangent is positive in quadrant 3. Quadrant 4, we're looking at this triangle here. So sine, negative direction, so sine is negative, cosine the positive direction, cosine is positive. So these two again, this time have opposite signs. Sine is negative, cosine is positive, so the tangent in quadrant 4 is going to be negative. So now what they've got written, they've got some relationships written that we're going to need for the questions in 14E. So underneath quadrant 2, they have sine pi minus theta is equal to sine theta. So remembering that we're always defining the angle 0 is along this positive x-axis, and whenever we're increasing the angle, we're always moving in this direction. And so if that's theta there, then negative theta is going to be in this direction. That there is negative theta. So that line there would be, this angle here would be negative theta. So what we've got is sine pi minus theta. So first of all, we can move pi radians in the positive direction, because the pi is positive. And pi radians is 180 degrees. Okay, so we're moving right, there's 90, or pi on 2, and there's pi around to here. And then we're subtracting away theta, so this angle here, so we're moving in the negative direction, theta. So that's going to be, that's the angle pi minus theta. So that's going to be this whole angle here. So that will be pi minus theta. And so sine of pi minus theta is, again, we're looking at this triangle here. So it goes down here and across here. And so we can see that that's going to be the same as sine theta, because this triangle here is identical to this triangle here. In other words, this little bit of angle here is theta. So we can see that this is always going to be true. The reason they've written it in under quadrant 2 is just because that's where you end up, right? So you go around pi radians and subtract theta radians, you end up in, as long as theta isn't greater than pi on 2, isn't greater than 90 degrees, you'll end up in this second quadrant here. And so that's always going to be true because we've got, over here we've got sine theta would be, if this was, let's say it's a unit circle, it's the length of this part of the triangle, this line here, from here to here. And then over here we've got this exact identical triangle, and we're still in the positive direction as well. So that's why we've got no negative sign here. So there's our sign there. Now they've also got cosine pi minus theta equals minus cosine theta. Again, we've just done the same thing here with this pi minus theta, right? We've gone around pi radians to here, and then we subtract theta radians, we end up with this same triangle. But now, so before we had our cosine here in the positive direction, now our cosine is the same length, but it's in the negative direction. So that's why we've got negative cosine theta here. Okay, it's the same value. And the final one they have, I'll try and write this a bit smaller to fit it in, is tan pi minus theta equals minus tan theta. Well, we already know that we're getting the same value for sine, the same value for cosine, just in the negative direction. So then when we do the same thing for tangent, we've got sine and cosine having opposite signs. So this one has a negative sign, this one has a positive sign in front of it. And since tan was defined as sine theta on cosine theta, where there's now going to be a negative here for the cosine, that's going to make that tan negative. And so that's why we've got a negative sign here. Okay, so in the third quadrant, by the way, you can pause this at any time and look at page 491 if you want, just to correlate what they've got written here with what I'm doing here. And so, and then you can even go to that web page that I linked to you a couple of days ago and just do this for yourself. Just pick some angle, 30 degrees or 20 degrees, whatever you want to pick. Note what sine, cosine, and tangent equal at that angle, and then add, and then do, so then you'll want to do, move around to pi radians and subtract that same angle. Say if you did 20 degrees, subtract 20 degrees. So you'd be at, this would be 180 minus 20, so you'd be at 160, and then note what sine, cosine, and tangent equal at 160, and you'll see that they'll be, for sine it'll be the same, for cosine it'll be negative of what you had for 20 degrees, and for tangent it will be negative of what you had for 20 degrees. Okay, so under the third quadrant, they have sine pi plus theta is equal to minus sine theta. Again, they've just written this in the third quadrant because that's where you'll get, if this is our theta, then if we go around pi radians to here, 180 degrees, now we're adding theta rather than subtracting, so we're going in the same direction, we'll get to here. So that's going to be this triangle here. And so now we see, again, it's exactly the same triangle as here, except now our sine is pointing in the negative y direction. So our sine, it'll be the same value, because this side of the triangle is the same length as this side of the triangle, because the triangles are identical. But we're just pointing in the negative direction, so that's why we have the negative sign here. So sine pi plus theta is the same as sine theta, just in the negative direction. And so then we have cosine pi plus theta is equal to minus cosine theta. Why? Because it's going to be exactly the same as what we got for cosine pi minus theta, because they share the same side. This triangle here shares the same x-axis side as this triangle, right? So the cosine here is in the negative direction, but it's the same length as the cosine here. So that's why we have this negative. And now we have sine is negative, cosine is negative. So when we divide cosine by sine, those negatives will cancel. So then we'll know that tan pi plus theta is positive. So it's just going to be equal to tan theta, the same as the tan for here. So then in the fourth quadrant, we have sine. Now we have 2 pi minus theta is equal to minus sine theta. So 2 pi is just 2 of what we did before. This was pi, so 2 pi has to be right around 360 degrees. But then, so we've gone 2 pi, then we're subtracting theta, so we have to move in the negative direction, and we end up there. So then we're considering this triangle that goes from here, here, here. And so again we can see this triangle still identical to our original triangle, but now our sine direction is negative. So we've got the sine, negative sign there. Again, if this is sine for theta, right, this length here, this length is the same length, it's just negative. So that's why sine 2 pi, go right around, minus theta is the same as minus sine theta. So this is sine theta here. This is sine theta. This is sine 2 pi minus theta. And we have cosine 2 pi minus theta is equal to cosine theta. Right, so again we're going around 2 pi radians, so there's pi right around 2 pi minus theta, back to here, considering this triangle again. Now they share the same base, so cosine is in the positive direction for both the angle theta and the angle 2 pi minus theta, which if you drew this for the angle, it would be right around to here. Right, so then that would be 2 pi minus theta. So this triangle are identical. Cosine is in the positive direction for both of them. So cosine 2 pi minus theta is equivalent to cosine theta. Which means that tangent of 2 pi minus theta is going to be negative, because we have a negative sign here and a positive sign here, opposite signs. It's going to be negative tan theta. So what we'll do in the next video is go over some of the questions that we were doing last week and see how we can just use these relationships to solve them.